Question number 9, carbon reacts with steam in a reversible reaction. So we have this reversible sign that indicates that it is reversible. So we are told that the enthalpy change is plus 131 kilojoule per mole. So it is greater than 0. So it's endothermic. But this reaction is reversible. So what does this one refer to? When you have a reversible reaction and you're given enthalpy change value, it always refers to the forward reaction. So forward reaction, that means from left to right, that means from reactant to product. Going that way is going to be endothermic. Now this reaction reaches an equilibrium if you do it in a closed container where nothing escapes at all. Well, you are asked why this reaction is endothermic, basically why the forward reaction is endothermic. As stated in the syllabus, you got to talk about bond breaking and bond forming. So if I start by talking about bond breaking, to break bond, you need to absorb energy. So it's going to be endothermic. You absorb energy from the surrounding. And then when you form bond formation is going to be exothermic when they will release heat energy to the surrounding. Now, why is it overall endothermic? We got to relate enthalpy change is going to be the total energy for bond breaking minus the total energy for bond forming. So you absorb energy for bond breaking and you release energy for bond making or bond forming, whichever word you like to use. Now, we saw overall is going to be positive. So to get this to be positive, this must be bigger than this, or you can go the reverse argument, this must be smaller than this. Okay, well, you just have to put it into words now. Delta H is greater than 0, overall endothermic. And the reason for it is because, well, we gotta talk about more energy is needed, more energy is absorbed to break bond. So you absorb energy to break bond compared to, or you can say relative to, the total energy release when you form bond. So I mean, some students really like to memorize this kind of thing, but there is really no need to memorize this, provided you know about this relationship. Then you can write this sentence based on this having to be bigger than this to give you something positive, which is just primary school mathematics there. Part B, this is about calculations. So when you form 1 mole of hydrogen, you absorb this much energy. So this thing here is 131 kilojoule per mole of hydrogen gas there. So when you form 240 dnk of hydrogen, so the first thing you do is the mole of the gas, meaning to say the mole of the hydrogen, which I will write as N bracket H2. This is going to be the volume of the gas. This is in dm cube. And in your periodic table at the bottom, you have the molar volume of gas at room temperature and pressure. It's stated that 1 mole of any gas, 1 mole of any gas occupy 24 dm cube volume at room temperature and pressure. So volume of gas in dm cube divided by molar volume of gas in dm cube per mole. 240 divided by 24, that is going to give you 10 mole of hydrogen gas. So we know that 1 mole of hydrogen gas absorb 131 kilojoule. So therefore, this is about 131. If I try and do my direct proportion, it might be better. So 1 mole of H2 will absorb 131 kilojoule of energy. If you have 10 mole of H2, this is going to absorb, 10 times the amount of energy. So hopefully that direct proportion should make sense to you. 10 mole over 1 mole, the mole will cancel out, so I get 1310 kilojoule overall. So that is in kilojoule, so that is as stated, as calculated in my calculation there. Part C, this is about predict with a reason how the positions of equilibrium will change. This is about position. Does it favor the forward reaction or backward reaction? Does it shift to the left or shift to the right? This is about increasing pressure when you have constant temperature. So we don't change temperature, we change pressure. Pressure affect gases. That's the first thing you have to think about. Pressure affect gases a lot, so you have to count the moles of gases on the left and on the right. On the left, we have this H2O as a gas, which is steam. And then on the right, we have the gaseous hydrogen and gaseous carbon monoxide. So this is a solid which doesn't count because solid don't exert as much pressure as gaseous molecules. We have 1 mole of gas on the left, 1 plus 1, 2 moles of gas on the right. So 1 mole of gas on the left. So there is 1 mole of gas. We have to focus on the word gas, okay, because pressure affects gases. And then what do we have? There is, well, 2 moles of gases. So plural there, 2 moles of gases on the right. Something about Chatelier Principle. So Chatelier Principle, so it's just the name of a guy, but you might not have learned this principle word by word, but you will have used them as you talk about how equilibrium position changes with pressure and temperature. Basically, Chatelier Principle says when you have a system in equilibrium, for a reaction in equilibrium, when you introduce a change to a system in equilibrium, the equilibrium will try to oppose the change. Oppose the change means counteract the change. It will try to go opposite the change. Okay, and when you increase pressure, so what would the equilibrium try to do? So when pressure increases, so we're trying to explain first before we state what happened to the position, obviously, yeah? The equilibrium will try to do the opposite. The equilibrium tries to decrease pressure. So the greater number of molecules of gases, the greater will be the pressure because you will have greater number of molecules of gases on the right hand side compared to the left hand side. You want to decrease pressure, so you will shift to the side with lesser gaseous molecule. So shifting to the side with lesser gaseous molecules. Based on our first point, which side has lesser gaseous molecules? So therefore, it will shift to the left. So favor backward reaction. So you could say either shift to the left or favor backward reaction. They both really mean the same thing because both of them will be talking about equilibrium positions, which I have started explaining first prior to stating what happened to the equilibrium position there. On to the next bit of the question. What happened when you change temperature, when you increase temperature, but now this is a constant pressure, so we don't look at moles of gases. Instead, when we talk about temperature, we need to talk about whether the forward reaction is exothermic or endothermic. Earlier bit of the question, we were told that the forward reaction is endothermic. We were asked to explain why the forward reaction was endothermic overall, and we did just that. Being positive enthalpy change there, it's endothermic, so the forward reaction is endothermic. We start off from there. Now, what happened with temperature increases? Well, the equilibrium will try to oppose the change. The equilibrium will try to decrease temperature. But what does your forward reaction do? It absorbs heat energy. So when temperature increases, equilibrium will try to oppose the change. Equilibrium will try to do the opposite. It will try to decrease temperature. And then, what does it mean by decreasing temperature? Well, you can either absorb more heat or absorb less heat. You want to try and decrease temperature, so obviously you absorb more heat, because if you don't absorb the heat, then the temperature is going to increase. So by absorbing the heat, you are removing the heat that was around to cause the increase in temperature. So you would go back to being in equilibrium by absorbing more heat to try and decrease the temperature. In the forward reaction, you absorb heat to form the products. Reactants absorb heat to form the products. When you absorb more heat, so therefore, we can say, therefore, equilibrium will shift to the right-hand side because your reactants absorb more heat to form more products. When you shift to the right-hand side, you will favor the forward reaction. So favoring forward reaction or equilibrium shifting to the right-hand side, that is basically stating what happened there to the position of equilibrium. But in both cases, whether it was pressure or temperature changes, I always like to explain first before I state what happened to the equilibrium position. Always been a habit of mine there. Part D, the reaction between carbon and steam is a possible source of hydrogen. So we know that hydrogen is used in a fuel cell. Fuel cell has some advantages because, it's a clean fuel where, hydrogen and oxygen gas combine together to give you only water byproducts. and this thing has to be balanced, 2H2 and 1O2 giving you 2H2O. So only liquid water get produced as a byproduct, and this is essentially combustion of your hydrogen in oxygen to give you water. It's going to be exothermic and provide you energy. However, this question is not asking you on advantage, it's asking you on disadvantage. Okay, so what can I say about the disadvantage of using this reaction as a source of hydrogen? Why is this reaction bad? It's not asking you on why is fuel cell having disadvantage, but it's asking you why this reaction between carbon and steam is quite bad. Well, if we look at the equation, yes, we get our hydrogen, but we also produce CO. And CO is a very poisonous and toxic gas, so this reaction produces carbon monoxide as well. In particular, it produces a toxic gas. So this reaction also produces carbon monoxide. And then this question is really about the dangers of carbon monoxide. So carbon monoxide has got one oxygen bonded to carbon, and then CO, basically carbon monoxide, is toxic, or you can say poisonous, in a way that it binds onto your red blood cells, the hemoglobin in your red blood cells, irreversibly, and therefore you're not taking enough oxygen in the body. It can kill you, obviously. Another source of hydrogen is to get the hydrocarbon, to do cracking of hydrocarbons. Basically, long chain hydrocarbon becomes shorter chain and more valuable hydrocarbon, and in doing so, you can get some hydrogen gas. What is one advantage? Advantage means good point. Manufacturing hydrogen from this reaction. Careful with the question. It is not asking you for the advantage of fuel cell. It is asking you for the advantage of the method in particular. So always read the questions and think about the question with regards to actually reading the question. So rather than from crude oil, why is it important? Why is it good that we get it from the reaction of carbon with steam? What can I say? Crude oil will give one advantage of manufacturing hydrogen from this reaction of carbon with steam rather than from crude oil. What can I say? Give one advantage of manufacturing hydrogen from this reaction. So what do we have? We're just reacting carbon and steam. So these two are readily available reactants. We have a lot of carbon. On Earth, we are organic life form. So carbon comes from wood, charcoal and stuff. Those are all carbon as well. I mean, diamond is carbon as well. But all those wood, trees, the carbons. So I mean, we get our pencil, they contain graphite, they contain carbon as well, right? So carbon and steam, they are readily available, whereas crude oil, they come from fossil fuels, so they are non-renewable. So crude oil comes from fossil fuels, which are non-renewable resources. Once you use them up, you can't get them back again unless they get regenerated over thousands of years, under pressure, deep in the ground. Whereas the reactants in this reaction, the reactants from this reaction, or the reactants used in this reaction, are readily available, are renewable. Essentially, it's just carbon and also water. Well, water vapor, which you get by vaporizing water. And that's the end of that 10 marks question there, really.